Hi everyone, in this video I am going to explain electricity. So when we talk about electricity, so electric current, first concept is electric current. When we talk about electric current or current, the rate of flow of electric charge is called as electric current. We can write current is equal to what? Charge flowing per unit time. So generally current is represented as I, charge as Q, time as T. So we can write I is equal to Q by T. SI unit of charge is coulomb. Okay, SI unit of charge is coulomb. Current is used in see, let's take a 1 coulomb of charge is flowing. Time SI unit is what? Second. So let's take a when 1 coulomb of charge is flowing for 1 second, then 1 by 1 is what? 1. Current is said to be 1 ampere or coulomb per second. Current is measured in coulomb per second, which has been given the name ampere. 1 coulomb of charge has this much electron, children, 6 into 10 to the power 18 electrons, whereas the value of electron, the charge of electron is minus 1.6 into 10 to the power minus 19 coulomb. Next, we talk about electric potential. Okay, electric potential is nothing but work done by electric field in carrying a unit positive charge from infinity to a point. Okay, so V is equal to what? W by Q. Let's understand, children. Let's Q charge is there at infinity. I want to know the potential of this point A. So what we are going to do? We are going to move this charge Q, okay, from infinity to this point A. So potential is nothing but work done, okay, by charge. Okay, amount of work done to bring unit positive charge from infinity to a point. So let's take, children, charge is a unit, okay, 1 coulomb. So we can write V is equal to W by Q. If Q is equal to 1 coulomb, children, so V is equal to W. So V is nothing but amount of work done to bring unit positive charge from infinity to a point. Is it clear? When two conductors are joined by a metallic wire, the direction of flow of electron is determined by the electric potential. Okay, the charge always flow from high potential to the low potential. Here you can see plus to minus electric field is there. Okay, whenever there is a electric field due to the positive charge is away from the charge and due to the negative charge is towards the charge. Electric field is the imaginary lines actually which represents the strength of electric field. So wherever there is a charge, there is a field. Potential difference. Here what happens, children? Okay, charge is moved from one point to other point. Okay, and amount of work done to move a unit positive charge from one point to other point is called as potential difference. So let's go to the definition. Potential difference between the 2 points is equal to the work done in moving a unit positive charge from one point to other point. Let's take point A is there and point B is there. So when you move a charge from A to B, so you have to do some work, right now. So potential difference is nothing but work done to move a charge from A to B. Okay, or we can write a potential difference VA minus BB is equal to W by Q. And SI unit of potential and potential difference both is volt only. Here let's take, children, 1 joule of work is done to bring 1 coulomb of charge from one point to other point, then potential difference is said to be 1 volt. Similarly, here in potential, okay, we learnt that V is equal to W by Q. Okay, if 1 joule of work is done to bring 1 coulomb of charge from infinity to a point, then potential is said to be 1 volt. Okay, they may ask you sometimes what is 1 volt. Okay, so you can express in terms of work done. It is nothing but amount of when 1 joule of work is done to bring 1 coulomb of charge from infinity to a point, then we can say potential is said to be 1 volt. Potential difference just now here 1 volt we can see 1 volt is equal to 1 joule by 1 coulomb. So 1 joule per coulomb is nothing but 1 volt. Next, okay, we can see the definition. Current and electric current is nothing but the rate of flow of electric current or electric charges. Actually, I is equal to Q by T. Current is measured by a device called as ammeter. S unit of charge is what? Coulomb. Current is measured in coulomb per second, which has been given in the same name, ampere. Yes or no? Whatever we learned so far, here summary is there. Electric potential, the work done by electric field in carrying a unit positive charge from infinity to a that point. Okay, potential difference between the 2 points is equal to the work done in moving a unit positive charge from one point to other point. VAB is equal to what? VA minus VB, that is equal to W by Q. Let's talk about the Ohm's law, children. Very important. Okay, this question is asked for generally 3 marks, 2 marks to 3 marks. Ohm's told that at constant temperature, potential difference across the ends of the wire is directly proportional to the current passing through it. Okay, so here, or we can say Ohm's law, current flowing in the conductor is proportional to the potential difference across its end and temperature remains constant. Or we can write V is directly proportional to I. When you remove the proportionality, you have to put a constant. V is equal to IR, whereas R is called as resistance. What is R called as? Resistance. It is a constant of proportionality. Okay, and SI unit is what? SI unit of resistance is ohm. We are writing the symbol like this, ohm. Okay, so V is equal to IR is the Ohm's law expression. Okay, so what is R? R is equal to V by I. Let's take when 1 volt is applied, which causes a current of 1 ampere, then resistance is said to be 1 ohm. Here some terms are there in electric circuit, we should know. Electric circuit, the continuous and the closed path of the electric current is called as electric circuit. Ammeter, to measure the current in the circuit, always connected in the series, okay, with a resistance. So ammeter is a device which is used to measure the current. It is always connected in series. Whereas voltmeter is a device which is used to measure the potential difference or voltage, and it is always connected in parallel. Key, so voltmeter symbol is like this, ammeter symbol is like this, key symbol is like this. Okay, or we are writing key as like this also. Okay, so to open or close the circuit, we are using key. Battery, power supply in the circuit. Okay, the battery. So actually you should know positive and negative, this represent a cell. Okay, positive and negative. Okay, if 2 or more cell is connected, it is represented as battery. Okay, okay, if it is like this, it is what? A closed key. Closed key is like this also, we can say. Open key, we are writing like this, open key or open key. Next concept is electric circuit. Let's see one electric circuit. Okay, electric circuit, a continuous and closed path of electric